This is question 35 from section 1 of the 2018 ENGAA paper. In this question, we're given a sector of a circle, S, and we're told that sector has an area of 10 pi square centimetres. And then we're told the angle of the sector S is increased by pi over 20 radians to form another sector, which we'll call T. And we're told that the area of this new sector T is 25 over 2 pi centimetres squared. And from all of this, we're asked to find the arc length of sector T. So this question concerns sector areas, arc lengths, etc. So let's write down some important formulas for that. So the area of a sector is given by this formula. So half times the radius squared of the circle times by the angle which generates the sector. And the arc length of such a sector is the radius of the circle times by the angle of which generates the sector again. So when I saw this question, the one thing I wish they'd given me was a diagram. But no worries, we'll just make our own. So here's the circle. Radius r, I've just left it as r because we don't know. We've got this sector in the black, S, generated by an angle theta. Theta's unknown. And the little extension to t, which is the addition of pi over 20 to the angle, generates this. Now, where do we start? I think finding the first thing to do in this is the tough part. But what do we know? Well, this is the only thing we know the angle for. So if we could work with this little segment here and try and find, say, r or theta or something like that, that'd probably be a good idea because this is the little bit we know most about. Because not only do we know the angle, we actually know the area of this. Because we know the area of t, which is 25 over 2 pi, and we know the area of s, which is 10 pi. So if we just do this minus this, we've got the area of this. So we have the angle, and we have the area, so we can work out, or should be able to work out, the radius of the circle looking at this little segment. So let's do that. So this is what we're looking at, and a half r squared times pi over 20 is equal to the area of this segment, so 25 over 2 pi minus 10 pi. And let's go for the algebra for that. So we can cancel the pi's. And 25 over 2 minus 10 is 25 over 2 minus 20 over 2, which comes to 5 over 2. And then we can cancel the 2's, times 3 by 20, and get r squared is equal to 100. And r is equal to 10. So we've made some serious progress. We know the radius of the circle, which is going to be pretty important for finding the arc length. So we've updated our diagram with the radiuses of 10. But now where do we go? So this is the length we want, L. So we know we need to do something with sector T from here. So what do we know about sector T? Well, we know the area. So why don't we shove everything we know about that in? So we know a half times the radius squared, 10 squared, times this angle, so theta plus pi over 20, is equal to the area of the sector, which is 25 over 2 pi. So you can see from here we could get out theta and then work out L from that. It would take a little bit of time. The thing is though, there is actually a nice little shortcut here. Because what is L? If we remember rightly, L is equal to r theta. So this is true, right? L is equal to the radius 10 times by theta plus pi over 20. So that's great because we've just swapped our equation theta. If we sub this in to an equation in L, so we just have to rearrange that and then we'll have L. So this becomes this, a half times 10L is equal to 25 over 2 pi. So L is equal to 5 over 2 pi, just rearranging that because we can cancel the 2's and then divide 3 by 10. We get 25 over 10, which is 5 over 2. So if L is 5 over 2 pi, that's good because one of our options is D. So our answer for the arc length is D.